Thank you, automateIT and Zenitech for giving me this opportunity to present the tools that we are using for automating audio and video, and also to give TestRay a possibility to show our capabilities to your audience. I will start. Of course, my introduction. So I've been working at TestRay for already 4 years. I'm right now head of research and development, and but I've worked in many projects related to automation, UI automation, API automation, and also I've worked as a developer for some of their internal tools that we have in TestRay, such as Loadero and Avimation, and others internally. And okay, I will start sharing my screen. Right. So as I said, I will be talking about audio video testing and using our own automation framework, which is called TestRay. I'm Alvaro Laserna, and I hope you like this topic and this presentation. It will be accompanied by a demo at the mid of the slides, so that I will showcase the TestRay examples that are in GitHub. So anyone that wants to test out these capabilities, you are welcome to clone the repository, install TestRay, and test out what you can do with very simple steps. First of all, I will give a brief introduction to TestRay and what we do. So we've been in business over 10 years with a world-renowned client base. You can see some of the trusted companies that we have been partners for quite some time. You can see it down there in the left corner, down corner, and we offer a wide range of testing services, going from functional functional testing, non-functional testing, and then we also offer development capabilities, and we have our own products, and eventually we also have our own publicly available frameworks, as the one that we are going to present today. For the audio and video department, we choose these to get increased over the last few years, because the amount of requests from different clients were increasingly due to the situation back then, and that is still ongoing, which is related to the pandemic. So here we can go to the whys and how we started this testing. Of course, before the pandemic happened, we had some audio video testing, but it was mostly focused on manual testing. We tested streaming services and some video call applications, but we didn't have such much demand because it wasn't like the main thing back then. But then right before the pandemic started, I joined a small team, which by the time I was the only automation person, and I took behind my wing, I took myself the responsibility to develop a full framework and a full process to automate the audio video applications, if it's a video call application or if they are streaming services. I will showcase one simple example. In this case, we are talking about a test between a mobile device, which is a sender device, and a receiver device, which is also another mobile device. In this example, we can see that the sender device is facing a monitor screen, which contains some markers on the left top corner. This video is recorded by the sender device, and is being sent through the application, let's say Zoom in this case, imagine that we are testing Zoom, is being sent to the receiver device. This one is the one that we are going to record, and that's why we are calling receiver device. It's not because they are not both sender and the receivers, but it's because we are using that as the one that we are going to test out and see what is the media quality from that end. Then we also have both devices connected to an audio card, which is directly connected to the sender computer. This sender computer will feed the audio to the sender device. So there will be a voice, a human voice, going to the sender device, saying some words, as I'm doing right now. And then the receiver device will have a degraded audio because of the network conditions, because of the application, because of the way things are set, which are tightly controlled by our automation setup. And these degradations are passed to the audio card so that we can record both original audio and degraded audio in sync. This way, we will compare both, and with our algorithms that I will show later, we can obtain scores that will showcase what is the audio quality and from the video quality. And I will go after the different metrics later on, but mostly all of these audio and video quality metrics are open source, and you can also clone them or download them and then install in your computer so that you can test them. Then you can also see that there is another computer and two routers. I will mostly talk about the routers because this is a very important part that we take very seriously in order to replicate real usage from users that have their phones in like very populated areas, in areas where the signal is not so good, in areas where like vehicles are moving or there are metallic surfaces. And so we have one device connected to one router and the other device connected to the other router so that we can control perfectly what is the data that is being sent from one device to the other device. And also we can simulate the network connectivity between these two devices, being able to simulate latency latency bandwidth, jitter, and also packet loss. Okay, so the steps for an audio video test case will go through these steps. First, the sender mobile camera is facing a monitor that displays the video to evaluate and initiates the call. The sender mobile audio comes from the audio jack, which is played through the sender computer. We use SOC, audio handling command line tool, to be able to control the playback. The receiver mobile screen records what is playing through the call. We use different frameworks, different command line tools, depending on which device are we using. But we tend to use FFmpeg together with some hardware. There is some hardware that allows you to forward the video from the screen of your device to the computer. This is called Elgato, but there are other options, and also there are other softwares that can accomplish the same thing. For example, iOS phones, you can use QuickTime to record the video. For Androids, you can use Screen Recorder, which is a command line tool installed in most of the Android devices. The receiver mobile redirects the audio to the computer so that we can record the audio. And again, we are using SOC for the audio handling. Now I'm going to further explain these technologies, this stack of technologies that we are using. As I said, these are all of them, they are open source. You can download them, install them in your computer and work with them. SOC is the one that we use for play and record, but also allows us to mix and change the audio files in different ways. You can explore more about this tool. It's quite useful, and yeah, I encourage you to take a look at it. The next one is a well-known tool for video processing. It's FFmpeg, available again in all operating systems. It's meant for video recording, formatting, and it also has the libraries to be able to analyze video quality. I will talk about that later, but VMAF, which is one of the video quality algorithms that are used for video quality assessment, can be included within FFmpeg, as well as other full reference metrics that I will talk about later. Wireshark and TCP dump are meant for handling network and network recording and analyzing network traces. TC, or traffic control, is meant for simulating network traffic, is used in Linux, and that's why well, most of the routers that we're using has Linux environments, and we use this to simulate network traffic. And finally, we come to our tool, our orchestrator, which is called TestRay. Again, this is open source. You can download it, clone it, and install it. The automation solution that we are proposing, this has been developed by TestLab, by my team, and we are continuing to improve our own, well, continuous integration tool. This CLI allows us to create automation pipelines on most modern platforms and applications and browsers. So if you think about automation, mobile, Android, iOS operations, browsers, desktop browsers, going from Chrome, Firefox, Opera, and others, and as well desktop applications on Mac and Windows, you can use TestRay to ease your work. Of course, TestRay uses Appium and Selenium underneath, so that's the main drivers. Those are the main drivers, and within the TestRay framework, there is a guidelines about how to install all the things required to make your automation work and useful. Well, these are some of the great features that we offer within this tool. First is easy to create automation pipelines. And this is not only for UI automation, you can use it for building pipelines for API automation to orchestrate even some APIs between the hardware and your software to implement different drivers running in parallel and synchronization among them. This was actually the main deal about this framework, because most of the available frameworks, you have to build very complex synchronization mechanisms to be able to have two devices and make a call between them, and then synchronize when one is calling, one is receiving the call, and pick the call at the right time. Then is build as modular blocks that can be reused, like starting call, recording a script, analyzing data, which means that you can build an automation for some application, but you can also build the same automation for a different application using the same scripts for recording, analyzing, and the only thing that you have to change is starting the call or ending the call. Then it has built-in Cucumber reporting, clear login in terminal, and easy installation. Okay, so let's stop the talking and let's go hands-on and explain how this works. Here are the links for TestRay and TestRay examples. If you go to TestRay, as I said, you have here clear installation steps. You can go to full installation, which includes prerequisites for TestRay. They are written for Windows and also Mac. There are some hints about how to solve some of the issues that arises from installing some small things about Android automation or iOS automation. And actually, there is a full page dedicated to iOS testing, which is pretty much by the end of the document. If you, for setting up real iOS devices, we have another document that will help you out through all the process on iOS testing, which in real devices, sometimes it gets pretty exhausting. So we worked on this so that any of you can take it and help you out with the installation. Then the other one is the actual TestRay examples, which I will jump in right now. Okay, so once you you clone TestRay examples repository, you will have these cases. Well, most important is the cases folder. The rest is small things. Within the cases, we are going to jump directly to the config.yaml file, which is one of the most important files at the beginning of creation of any TestRay automation pipeline. In the config YAML file, you will have roles, and you can have also environments. Environments are not necessary, but roles are mandatory, because the roles are going to be the drivers that you are going to use for your testing. The roles can be, as I said, desktop. Here we have 2 desktop Chromes, because we are going to do the testing in my computer. I'm going to conduct real-life testing on my computer using 2 desktop Chrome windows that will call one to each other. We have an example of how to initiate a desktop Firefox, and you can see that this is pretty much all you need to create a desktop Chrome or a desktop Firefox driver, nothing else. The other 3 roles are command lines, and these are going to be used for recording and analyzing data. I will explain a little bit later why we need 3 command lines, but the answer is going to be pretty straightforward. There are several examples of in this repository that showcase different things, but for our case, I'm going to jump in directly to case Chrome example, which is within cases and within audio video cases. And then here I will jump to the actual main case, which is I will open. We can actually read in Gherkin language. As I said, the framework has built-in Cucumber reporting, and also you can define every of the steps as Gherkin language, so that you can easily build your pipelines and that you can have them in a readable language for you and for stakeholders. We have given, I navigate to the video app page on call, which happens with 2 drivers, 1 desktop Chrome and a second desktop Chrome. Then I limit the network. I start recording audio, video, and traces. I end the call with both of the drivers. And finally, I start analyzing audio, video, and traces. Those are the steps. It is as easy as it gets. And the only thing that we've done is, well, define a series of variables here, say that we are going to run everything in parallel, because this will fasten up things. And also we have defined the roles with a series of capabilities for Chrome. I will explain that right now. And also the 3 command lines. Let's jump into the Chrome instances. We have defined that with these 3 first Chrome option arguments, which are used for faking the media stream that is sent to the browser. This is for both audio and video. And this will allows the browser to access those media files and to recognize those as media input for the camera and the microphone. And then we are using specific media files for the audio and for the video. I have pointed them to internal video references, but you can use whatever video. The only thing is that you have to format it to .mjpeg file or to .y4m. Either of those will work. The only thing is that .y4m is very highly uncompressed video format, and a 10-second video might weight almost about 1 gigabyte. So that's why I often transform it to this format instead, to ease things up. About the 3 rows, the 3 command lines. Okay, this is quite like a straightforward reason. We are recording audio, video, and traces. So we have pretty much 1 command line for the audio, 1 for the video, and 1 for the traces. And since they are parallel roles, they will run in parallel, and we will be able to record these 3 metrics in parallel. Okay, so now that we have understood at least the main case, let's jump to the step definitions. I navigate to video app page, and we have this step. I navigate to video app page. Here, things are going to be more familiar for those who have worked with Selenium or to browser testing. We have first navigate to a URL, which is the application for testing. Then we are going to click with the strategy ID and with the locator start button. And then we are going to maximize the screen so that it fits the full screen, and we can test that. As you can see, one interesting part to notice is that this navigate to WebRTC application case is actually a case, which means every case can be a step. And which means that we can do that repeatedly and have cases within cases. And you can go through that rabbit hole as much as you can. You can put a case within a case within a case within a case, and almost forever. And now what I'm gonna do, because I'm talking quite a lot, I will make the first proof of how this works with only this part of the case, which is navigating to the video app page and call. To execute a case, the only thing you have to do is TestRay, execute, and the name of the case. Well, it has gone very fast because automation happens to be very fast. So if you want to understand that that has happened, you can add in the end of the case a sleep of, in this case, well, I will put 5 seconds, and then we can see that things are happening. Here we have. Okay, so as you can see, this for creating an actual case, this is all the code you need. It will do the before hook of creating the drivers, the afterhook of deleting the drivers. It will do pretty much everything under the hood, and you will only have to worry about writing the simplest code that can ever be written with any of those tools. So these pretty much less than 20 lines of code will control everything. Now that we have seen the first, which is I navigate to the video app page and call, let's go to the I limit the network. In this case, since I'm working through my computer, through my network, I couldn't write a meaningful case for I limit my network. I'm just printing out that I'm limiting my network. But if you want to know more about how to work with this, in most cases, what we will do is communicate with SSH command to our router that contains the Linux server, so IP of the router. And then we will run a command line, which will be probably a wrapper of TC command. So something like sh wrapper tc.sh with the parameters of our limitations, which could be like 3000 kilobits, then 0 round trip time or latency, then 5% packet loss, and eventually 1000 queue size. I'd like to go more in depth of what these numbers mean, but in this case, I rather continue with the capabilities of TestRay. If you want to know more about this, you can ask it in the questions and answers by the end of this meetup. Okay, now we continue with I start recording audio and video traces, and traces. We go to the definition, and we have these 3 command lines, which executes first tsark command line, then sock command line, and finally ffmpeg command line. The first one is to record traces. We use interface, this environment variable, to understand what is the interface to use as trace recording. The interface is identifier to understand what of the possible network connections you are going to be recording in your computer. To know which one is being used, and when I mean different, imagine that you have Wi-Fi, you have Ethernet, and you have another USB with Ethernet ports, so you can have multiple network interfaces, but only one of them is going to be used for your network usage. In this case, you can know which one you're using by opening Wireshark and looking in the capture folder, capture tab. In my case, I'm using Wi-Fi, and it's called EM0. This is the internet interface that I'm using for my connection to internet. This variable was defined in the case, and as you can see, I defined it as EM0. Then we have time, which is the timeout for a recording trace. And now we jump to SOC. SOC, we have a series of variables, of flags. This is recording quiet. This is record at this sample rate. Then we are using this driver handling. For Mac is core audio. For Windows is called differently, so you will have to look at the documentation of SOC command line tool if you want to use it on other operating systems. And then we have the name of the file that we are going to record, and again the timeout for the recording. Lastly, we came to the FFmpeg, which will record the video. Again, we are recording in quiet login. This is to overwrite any files that have been written with the same name. This is the driver, the same as with the audio. So this is the driver to handle video recordings on Mac operating system. The time again, and this is the video input that we are going to choose to record our screen. How can you know what is the video input that you need to choose? Well, there is this command line here, ffmpeg-f ab foundation list devices true -y and quotes. If you run this line, you will get a list of devices for video and for audio. And in my case, I have Manycam virtual camera, my FaceTime HD camera, and the capture screen 0, which is the screen, the screen for for my device itself. Okay. Now we have the recordings. Again, they run in parallel, so we are recording all these things in parallel, and we can have metrics for each of those media files at the same time. And then we end the call. In this case, is stopping the drivers. So we are doing a forced stop of end of the call. Normally, you will click on end call button, but in this case, we are just stopping the drivers. And the last one, which is probably one of the most interesting, is the analysis of audio, video, and traces. Here, we use sock command line to transform the call.wav to 16 bits. This is for vscol evaluation. vscol is the algorithm that we are going to be using for audio analysis. Again, this algorithm is open source, and I created a Docker container so that you can download it and you can use it freely. The interesting part about this Docker container and this vscol version that I developed myself is that it delivers audio delay as well as audio quality. Then the result of this audio analysis is grabbed with this part of the code, and then this sum variable is written into mos.txt file. Then the next step is the one that we are using to analyze the traces. We use this QCDA flag to analyze the stats and then write them in trace text file. And the last one, this one is the only thing that is not publicly available, which is a wrapper for the video analysis metrics that we are using internally. This includes the processing for Vima, well, from different metrics that I will talk about later. And this is the only thing that is not public, but you can actually develop your own command line tool or your own script so that you can analyze that video with the publicly available frameworks that I will showcase later. But in this case, this is our own take, and I will show what you can get out of the video. And this is it. I've made the explanation of the full thing. So now let's go to the actual action, which is running the case. The time is defined as 10 seconds. I didn't want to run it for longer because otherwise this presentation will take for way too long. TestRay, execute, and case web RTC. Here we have our video. As I said previously, we had these Aruco markers at the top left of the screen. And this is used for frames per second and also to get the region of interest of the screen. Again, I will explain that later and how that's analyzed, but right now I'm just showing how this works. We have already analyzed the album. Now it has also analyzed the traces. We can actually see it here. So we have trace. Then we have the audio. So trace, audio analysis, and now it's analyzing the video. This is the one that takes the most time because it has to decode 60 frames per second. It has to analyze the frames per second that happens. And then hopefully I am, yeah. And then it has to analyze also the picture quality of all of those frames to understand how everything looks. It normally takes about 1 minute, so hopefully with this explanation, it will be enough to keep time to the algorithm to process this media. Yep. So it has ended 60 seconds, as I said, 1 minute. And we have a lot of new files that includes frames per second. So 25, 20, 10, 15, 15, 16, 14, 15, 14. The second column is pretty much the same. It's related to the confidence intervals on maximum and minimum frames per second. In this case, is the same in both columns. So just look at the one in the middle. We can see that the frames per second were going down. The reason for this is that my computer has limited resources and it can't really render as many frames as I'd like it to run, because I'm having also a video call at the same time. I'm doing other background processes. So in most cases, you will want that just the application is running and nothing else. Then we have VQTDL metric, which is, this is every second picture quality. Again, I will talk about it later. It goes from 1 to 5, being 5 the highest possible score and 1 the lowest possible score. So the average of VQTDL is about 3.9, which is good, but it's not excellent. The reasoning for having lower quality is because the rendering capabilities and the compressions from the applications degrades the media input, and so that they can send it successfully from to the other end. And this way, if we have 3.9 in this application, but then we have 3.5 in a different application, we will see that our application has better quality than the other one. Then there are a bunch of other files which are used for debugging and others that are quite useful. We can get the amount of blue color on the screen, the amount of red colors, and the amount of and this gives information for the development team if they want to debug a problem. Like there is a drop in quality and they want to understand if it has been because there is a lot of blur. This gives you the amount of blurriness that is in an image. The lowest, the better, the highest, the worse. And so if you have bad video quality and suddenly these numbers are skyrocket, you can understand that from the application end, they are applying a lot of compression, they are blurring a lot of image so that they can provide to the other end the quality that is needed with that network limitation. And yes, pretty much this is the showcase for the full case, for the full video quality assessment. It's a simple case, but it still is very meaningful because it shows you how the full workflow works and how simple it's actually to automate one of these cases. Last thing is that I said that it included Cucumber reporting. And in the README file, it tells you how to generate this report. The only thing that you have to do is install this reporter, this npm reporter. Once you install it, then you have to do node index.js, which is a file that is already in the repository, and point to the JSON Cucumber report for that specific case that we have run. And we can do like reports, logs, Cucumber case, webrtc.json. And here we have our report with our scenario. In case there will be a failure, you will have an image of the failure. And of course, I will also demo that because why not? I will make it so that the first step actually fails. And how to do that? Well, I will just put a wrong locator. I will put 1, 1 here, and this will make it fail. So it should be clicking in a start, but of course it's not clicking because the locator is wrong. Then it fails and it tells you, well, there was an error in case that, well, webrtc. I navigate to video up page and call element start button 1 is not visible there. Now we can generate the report again. And in this scenario, we have the screenshot with the problem. That's everything with the error. So yeah, nice. Is there any questions up until here? I see in the chat that there are 2 texts, but I'm not sure. Okay, I will answer this question. What happens with the roles when you have a case inside another case? Don't they override each other? So for this, I haven't explained it further. We have in this example, I navigate to video up page and call. And we are actually specifying these 2 roles. But when we go to the definition, we only have 1 role. So actually, as your question suggested, the first role defined in the case is the default role. And then from the uppercase, it has overwritten the roles that were defined in here. So you can actually pass in the parent case which roles you want to execute for the child case. So yes, good question. And in case you were wondering, the way to increase the amount of users, imagine that you want a 3rd user to join the call as well. What you can do is, I will actually just run it from the actual like smaller case, because it will be simpler than running the full case. I can put this here, and I can add another role, desktop from 3. But of course, I first need to define it in the config file, which I will call it here, desktop from 3. And as simple as that, I will put the sleep in the end so that we can observe that things are happening. We can TestRay execute this. And here we have 3 browsers doing exactly the same thing in parallel. We're going to fail because we have the wrong locator. But yes, again, this was the way to spawn more browsers if you need it. I will turn back. I will put this correctly, and yeah, be good. Okay, I will continue answering questions. How do you does network limitation work on any router, or it has to be a specific one? It works as long as it's a Linux-based router. We have special routers to do that. To that kind of that kind of configuration, that probably will need a different meetup. But yes, we have actually, they are not super special, but yes, it's not like your home router is going to be able to do this. You need a specific router for this. How do you distinguish acceptable audio video quality? And we saw some numbers, but maybe there are any guidelines, what numbers to expect. Yes, this is a good question. I will continue answering that probably later, but to give you an overall idea of what is good, acceptable audio and video quality, for audio quality, and well, MOS scores, if the MOS score goes from 1 to 5, normally we have good quality, like excellent quality above 4. We have acceptable quality from 3 to 4. We have poor quality from 2 to 3, and unusable quality below 2. In some cases, below 2.5 is already like no-go, and audio quality below 3 is no-go, like you can't use that. But there are, as I said, like for video quality, you have picture quality, which is that VQTVL metric that I saw before, but you have also frames per second, which is almost as important as the picture quality, because you can have a very pretty image, but completely frozen. And so the video quality will be unusable in that case. And the same goes the other way. You can have like a really bad picture quality, but high frames per second. But if you can distinguish anything from the video, why are you going to have like high refresh rate? And for audio, it happens something similar. You can have very good audio quality, but huge delay. And if you have higher than 1 second delay, the audio becomes unusable. At least not in this case, not in this meetup, because I'm the only one speaking. But if we have a conversation between ourselves, then we will step over each other and the conversation will go nowhere. So those are the numbers, at least. Are all the tests shown run on a lab setup, shown at the beginning, or is running on your PC? The tests that I've shown are running on my PC, because I wanted for you to understand that you can actually run a case within your own computer, and then you can escalate that to external devices using remote Appium URLs or remote Selenium instances, and handle different devices in remote configurations. But that doesn't mean that like I wanted to give you the demo that is wrapped in your own computer so that you can play with it and then develop upon it. What homework has to be done so that this setup also that good work? Probably need this whole setup. Yeah, this kind of is going to the same thing. It actually needs the setup that I showcased at the beginning. For mobile testing, we have this setup, which includes like a series of devices. It can be an Android. We always work with real devices. This is very important to understand what is the end-to-end behavior and what is the behavior for the application on a specific device. We mostly use the most used devices for that specific platform, that's the specific application, but we can test on different devices. And at TestLab, we have like thousands of real devices that we can actually use and test with. Because if the client wants exclusively to understand what is the media quality from without the devices, then they can use their APIs to retrieve that data, and then they can use the algorithms that I have shown and that I will actually show later to acquire that quality, that media quality. And it's possible for next season. I would love to see meetup dedicated to lab. Okay, yeah, actually, I will gladly I will gladly join to another meetup session if automateIT ask me to. This is very interesting. Okay, I hope I haven't skipped any questions, but I will now continue with the last part of the presentation, with which is just a wrap up of this. It won't go much further, and yeah, I will just explain a little bit what we have done, what are the metrics that we are working with, and also what do we use those metrics, like what is the report that we deliver to the client, because actually as much as this is like a nice showcase, we need to somehow deliver the data, sort it, and do it in a visual way, so that everyone understands what is happening and how to improve their applications. Well, first of all, let's wrap up the TestRay framework. We have the UI interactions that we have seen that works with these wrappers of Appium and Selenium. Then we have media recordings that goes through command line tools. The media analysis, which again goes through a command line interface tool. And in the end, there is a case that is not included in the demonstration because it doesn't make sense in this demo, which is sending the data to a server that represents the data, so that you can see visually what are the averages of this application in this network condition, what is the overtime graph, and all those results sorted. We have a solution for that internally in TestRay, but yeah, each of you can work with that the way you want. This is like it is an important thing to showcase what you've done, but anyone can do this work afterwards. Okay, for the video analysis and metrics, I mentioned it previously. We have these Aruco markers, which we are using for frames per second calculation. These markers, we tend to use 30 frames per second change of marker. This is because almost all of the application don't work higher than 30 frames per second. If they could, we will increase the refresh rate of these change markers to 60. But for our case, most of the applications, 30 is more than enough. And we also use the markers to get the region of interest for image quality prediction. So we get these two metrics, frames per second and image quality. Here we have overtime graph of one of the metrics. In this case, I'm showcasing Brisk. Brisk is publicly available. You can there is a repository with it, and you can work with it. The only thing is that the base model doesn't work so good, so you will have to actually train Brisk to be able to have like a meaningful model to predict quality on video calls. That's why, like at TestRay, we have put a lot of resources to make video quality a meaningful metric. And we can see the overtime graph here. So the overtime graph, this is a scenario. Sorry, this is a scenario that starts from a limited network condition. Then it goes to 1% packet loss, 5%, 20%, 5%, 1%, and unlimited again. We can observe that application 1, 2, and 3 behaves pretty good packet loss situations, but application 4 has problem with packet loss situation, where the higher it is, the lower is the image quality. And we can see that examples of 4 image quality and 2.5 image quality here, where the quality got heavily degraded. This already gives you an idea of what is the immediate output for the client, so they can understand by benchmarking different applications how their application is handling specific network limitations. And I told at the beginning that there were areas with like highly populated areas or with metallic surfaces, and those metallic surfaces normally create packet loss situations. And in those situations, we will see that this application starts behave worse than the others. For video analysis metric, and specifically for well, picture quality metric, I know VMAF has also a temporal feature. So in this case, VMAF also work as full video analysis metric, but we often use one metric for picture quality and then frames per second for the temporal quality. And well, I will go for it. We have to divide the video analysis metrics into two different algorithms. Full reference, which means that we are comparing the original source to the degraded source, to the degraded input, well, media that is received in the receiver device. And then, well, VMAF, it uses spatial and temporal feature extraction with a machine learning algorithm to predict a score. This is developed by Netflix and is one of the most used video algorithms right now. Then we have PSNR and SSIM, which are one peak to noise ratio, and the other one is structural similarity index. These are this is pretty much just a formula that takes the pixel values and then compares from the degraded to the original, and then it gets a score. So there is no like higher intelligence in this kind of algorithms. It's just a mathematical formula. Now we have also non-reference algorithms. We have BRISC, which is also a known algorithm to predict picture quality without a reference. So you just give an image and it will return a score without having any reference behind. And we have our own metric, VQTDL. This is developed by the R&D department at TestRay Lab that I'm leading currently. Is a convolutional neural network that uses transformer encoded and uses ResNet 50. This is kind of like big words, probably for those that don't haven't worked with artificial intelligence. And these will sound like Chinese, but well, it's pretty much a neural network that takes the image, analyzes it, extracts features, and then returns a score. And we have developed inside, we have worked quite hard to give the best and most stable quality metric that right now there is so far, or that we know of. And yes, stay tuned, because we have already published some blog posts about it, and we have this tool available for, well, for different purposes to different people. And if you want to know more, please contact us. Now the video analysis metrics, we're going to talk about frames per second and freezes, which is the other part of the equation. Frames per second, we use the markers to measure more reliable the frames per second. And we developed an algorithm that uses SSIM to check the difference between consecutive frames. And this means, like, if one frame is different from another one, then we have a change of frame. If we do that for all the frames through 1 second, we will get the frames per second. It's as simple as that. And for freezes, we use the same methodology. The only difference between freezes and frames per second is that freeze is for how long there hasn't been any difference between consecutive frames. And note that high frames per second not always means that there won't be significant freezes, because you can have 30 frames on 0.1 second and then have 0.9 seconds of freeze, and you will still have 30 frames per second. But the thing is, the video will be very clumsy. It will be like speed up, then freeze, speed up, then freeze, speed up, then freeze. It's very annoying to watch something like that. And this can be caused by jitter, packet loss, well, things like that. So if we have these kind of situations, we can immediately report to the client that they are probably having some problems with handling jitter or packet loss situations. The audio analysis metric, this is simple. We have either vSCOL or Polka. vSCOL is the one that I have showcased because it's open source, and in the end I have appendix with the URLs for these tools. But Polka is licensed, is actually it's good, but if you want to use it person as a person, probably you won't get it, because it requires they only license to big companies, well, to yeah, to some kind of, I'm not sure what is the number, but yeah, it is not so easy to get a license for Polka. And then, well, we have a reference sample compared to the grade sample, command line tool, we get the score and the delay. That's it. It works the same for both, and that's what you get afterwards. And we are almost ending. What to do finally with the data? For audio video quality metrics, they can be used for first overtime graphs of performance. You can have like a test from like 1 year up until now, and then you can see what is the performance through all the years that you've been testing the application, and that gives you an input of how much development has been put into this application. So I saw that at the beginning of the 2020, when we started this project, there were plenty of applications that packet loss was handled very poorly, and then now some of those applications are much better at handling that network situation, and we can see that in the overtime graphs, and we actually reported that to some of the clients that we had, so that they could improve their application, and they could put more effort into developing them that handling. Then you can also use it for benchmarking against other applications and platforms. And now with all the competition, all the new applications that have risen out of this situation, it's very important to have the best, because otherwise people are just going to use the main ones. And but if you have one that will show very good quality along all kinds of network conditions, then you will be in the top of this competition. And then validating quality standards by applying thresholds of acceptable values. Imagine that you have these 3 network limitations that most of the users are often facing, and you say like, well, we can't go below 3 for any of those 3 most score below these in these network limitations. And if we go, then we have a problem. And then you can actually use these metrics to raise as bugs to the test management tool, or to whatever tool that you're using for reporting problems on your application. And lastly, catching bugs, because of course we have actually catch some bugs along the way. These are related to, again, we had an example recently that one application in bandwidth, in heavy bandwidth limitation, just the video completely got frozen. And then they got that information immediately because we have this test running 24/7. And we also like inform them, hey, you have a problem with this network limitation, and they actually caught a bug which was related to the bandwidth estimator that they had from their side, and then they fix it, and everything was fine. Okay. So here are the links and some mentions to other frameworks that we have developed in TestDevLab, such as Speed UI and TestUI. These are the frameworks for UI testing based on Java and Python. So if you are more comfortable with other languages, we have also covered that. The TestRay and TestRay examples that I have showcased, the Vscol GitHub repository, which the only difference between my Vscol, over Vscol, and the Vscol version from the original page is that in this version, I've used it to extract also audio delay and the sample adjustment. If you want to read more, I encourage you to look into it. And then the other one is the Dockerized version, which is the one that I've used in this demo. You can again go for it, Docker pull this Vscol version and use it either as a standalone, like a command line tool, or you can also use it as a server. So you can actually send your audio degraded and audio original, and it will give you a score through an AP call. So yeah, plenty of things. And here we are. Well, these are QR codes for first TestDevLab careers page. And we also have TDL School, which is our own platform dedicated to teach all of the people that is interested in learning about QA, developing, and all the things that we do at TestDevLab. You can jump in and you will see if there is anything interesting, which I think that truly are. And before I end, I will see if there are any other questions. Why do you need a phone sender to watch the video on other screen? Why not use the phone itself, open video online from file phone? Yeah, the problem is that phones don't allow to inject media files into the phone unless you use screen sharing. And the problem with using a screen sharing is that most of applications don't handle the same way screen share than actual video feed. Because for a screen share, you need the highest possible quality without that much caring about frames per second. And so they change the way they are dealing with media when you are doing the screen share. And what I mean with this is that there is an actual way to do a media feed into devices, because that will be a security breach on Android or iOS devices. That's why we use external monitor to face the camera from the sender device and record what is playing from the monitor. As I understand, most of users just open and watch videos on their phones. Yeah, that's actually right. Who provides, or where do you find parameters for limiting network, limit bandwidth, packet loss, latency? Reflect particular region. To reflect particular region, you can actually go to a speed test, and they have actually a map of how the network is behaving in that specific region. But we also have some insights about what can cause different network situations. As I said at the beginning, So the last question, whenever you want, just apply. And so if, for example, I showcase this example of an area with like, imagine that you're going in a train, and trains usually have metallic surfaces, and in these situations you have packet loss. You can have quite good bandwidth, but packet loss will give like quite some problem. And also you can have jitter because of this movement, changing repeaters from like 4G, 3G network. And of course, if you go to non-populated areas like a mountain or some like countryside place, yes, you can have low bandwidth limitation, and you want to understand also how it works there. But normally, what we will offer from TestLab is a bunch of like network scenarios that will cover most of these situations. And yeah, that's pretty much it.